Okay, these are some more problems from section 9.4, and we're just going to try to find the radius of convergence in these, and this starts with number 21. Okay, we've already gone over the other ones, and this was a series, x plus pi to the n over the square root of n, and the summation as n goes from 1 to infinity. So we're going to use this limit, and we're going to use the ratio test. So we're going to try to take the limit as of a to the n plus 1 over a to the n, and that's going to equal L, and that's going to converge whenever L is less than 1. So hopefully we can find a value that will work. So I'll write my n plus 1. So this is x plus pi to the n plus 1 all over the square root of n plus 1. And I'll just, instead of dividing by this, I'll use the reciprocal, multiply. So the square root of n over x plus pi to the n. Now I wrote this out. So this is x plus pi to the n times x plus pi all over the square root of n plus 1 times the square root of n all over x plus pi to the n. These cancel, and I can put all my n terms in front, and then x plus pi. And then we know the limit of this, we could put it all in the same radical, and it doesn't matter because as n gets really, really, really big, this is going to be just like infinity over infinity, which is 1. Square root of 1 is 1, so that's just, that whole limit's going to go to 1. The limit of that goes to 1. So we just have the absolute value of x plus pi. That's going to be my L. And that's going to converge whenever L is less than 1, so I just set that less than 1. And it looks like I've got it in the good form of x minus a, so since this inequality is less than 1, that would give me the radius of convergence of 1. I could later solve the inequality for the interval of convergence, but we'd also have to check the endpoint, so we'll do that later. Chapter in 9.5. Okay, take a look at number 22. And number 22, skipped a few more steps here than I normally do, so hopefully you can follow it. If not, just kind of work out and add those extra steps. Okay, first of all, this was my series, x minus the square root of 2 to the 2n plus 1 divided by 2 to the n. It's not a geometric series, so I'm going to use the ratio test. Again, we're going to try to find this limit L. And then whenever that's equal to, or whenever that's less than 1, it will converge. So first of all, I took this, and this is the n plus 1. So x minus the square root of 2, and 2 times n plus 1 plus 2. But n plus 1 times 2 is 2n plus 2 plus 1 is 3. So it ends up being 2n plus 3. Because if I put n plus 1 in for n and simplify, I get 2n plus 3. All over 2 to the 2n plus 1, and then times the reciprocal, which is 2 to the n, all over the reciprocal of this, which is x minus the square root of 2 to the 2n plus 1. So I kind of did my simplifying over here, so watch what I did. This ends up being this binomial to the 2n plus 3, and I have this binomial to the 2n plus 1. So if I divide or subtract, if I subtract 2n plus 3 minus 2n plus 1, the 2n's cancel, 3 minus 1 is 2, so I get this to the second power. Now, in the same respect, I did kind of this. This is like 2n, and this is like 2 to the n plus 1, which is like 2 to the n times 2. So the 2 to the n's cancel, and I end up with just a 2. So take a look at that. You might have to put an extra step in there. Probably if I wrote this out again, I would have put that extra step in there. But these simplify to be this. So that's my L. Because what happens? No n's. So if I take the limit as n approaches infinity, do you see any n's? No. Got rid of them all. So that's just going to be, no matter what n is, that's that. So that's my L. So as long as that's less than 1, it will converge. So by the ratio test, converges when L is less than 1. This is my L. So when this squared is less than 1, that's my L. So what I do is, first of all, I multiply both sides by 2, and then I take the square root of both sides, and there's my radius, square root of 2. Okay? So if that makes sense. Okay, and here's number 23, where we're actually finding the interval of convergence, and the only time we can do that right now, at this stage of the game, is as long as it's a geometric series. And that's what I have here. In other words, if I look at the summation, x minus 1 to the 2 and all over 4 to the n, I can rewrite it like this. And I can rewrite this like this. x minus 1, 2 over to 2n. I can write it like this. And you can see now that we have a common ratio, x minus 1 over 2 squared. So it's a geometric series with r equals x minus 1 over 2 squared. You can see how I kind of simplified this out and showed that it was a geometric series. So take a look at those steps there. All right. Now that I have that, I know that a geometric series converges when r, the absolute value of r is less than 1. So I take the absolute value of this and I set it less than 1, which is the same thing. If I take the square root of both sides, if I take the square root of 1, I get 1. So that's the same thing. Then if I multiply both sides by 2, see what I have. And then if I remove my absolute value, I'll just say that means this is going to be between greater than negative 2 and less than positive 2. And then if I add 1 to both sides, or add 1 to all three sides, that's going to be negative 1, x, and 3. And there's my interval convergence, negative 1 to 3. They also want you to define this. They also want you to define the sum of the series and in as a function of x. So that gives us a little bit of leeway there. So we wanted this as a function of x. So this is s of n, which is 1 over 1 minus r. Remember, that's our geometric series. I know what my r is. My r is x minus 1 over 2 squared. So I just say 1 over 1 minus x minus 1 over 2 squared. And then I just have to algebraically simplify it. Also, first of all, I can remove this parenthesis. I can square this out, so I can remove the parentheses. So I get 1 over 1 minus x minus 1 squared over 4. Then because 2 squared is 4. Then in order to get rid of this complex fraction, I'll multiply the top and bottom by 4. So I get 4 over 4 minus x squared. Then I square this binomial out. Then I multiply everything by the negative. And then I simplify. And then I just factor out a minus sign because this book likes it. No, pardon me. Here we go. Okay, so here I multiplied everything by a negative sign. And then I just combine these. 4 minus 1 is 3. And then, so I have this nice simplified form, but the book doesn't like a leading negative sign, so I factor out a negative. And that becomes a negative times the whole fraction. That becomes positive, negative, negative. And there you go. So I think all the steps are there. So I think that should make a lot of sense to you. Okay? That was 23. And then 24, I think actually kind of wrote that up a little bit better. Yeah, here it is. Okay. There's 24. It's very similar to 23. Matter of fact, they're kind of clone problems, so I just gave you more of them just to get more practice. So this is 24, and it's almost identical. It's the same idea. So just take a look at it. This is my summation. This is my series, and I can rewrite it as x plus 1 to the 2n over 3 to the 2n because that's like 3 squared. And then I can rewrite it like I did before in this form, and it looks like I've got the x plus 1 squared over 3 squared. You put that all over squared. Okay. It's x plus 1 squared over 9. It's the same thing to the n. So I kind of simplified it out. So you can see that this is your r. So as before, it's a geometric series. This is my r. So it converges when r is less than 1. So I take the absolute value of x plus 1 squared is less than 1. So I could take the square root of both sides, and I have this. I also put this on the bottom because this, the absolute value of 3 is just 3. So that should be no problem there. You remove that absolute value. I hope you realize that. Then I multiply both sides by 3, and here we go. And then we just write this as an inequality, this absolute value. So this is going to be greater than negative 3 and less than positive 3. And then if I add 1 to both sides, or I'm sorry, in this case I'm going to subtract 1 from both sides because I got a positive 1. I can have negative 4 less than x less than 2, and that's my interval convergence from negative 4 to 2. It's open because it's a geometric series. Then we wanted you to find the sum. So remember, the sum is a function of x. And here we go. This should be pretty straightforward. Hopefully you can follow this. S equals 1 over 1 minus r. That's our geometric series sum form. And this is 1 over 1 minus, and this is r. And then I just squared this out, so I get x squared over 9. Then I multiply the top and the bottom by 9. So I had 9 over 9 minus, and then I had x plus 1 squared. 9 minus, and I multiply this out, x squared plus 2x plus 1, just a binomial squared. Then I remove the parentheses, negative x squared, negative 2x, negative 1, then I could combine. What's 9 minus 1? 8. This is what we have. Then we factor out a minus sign and put it in front. So I've got 9 over, or negative 9 over x squared plus 2x minus 8. So just reverse all the signs. Okay? That's 24. So I hope those all help.